Okay, hello everybody, and it is focused on me. We love that. Do you want to know why? Because I am one of your hosts for today. Why am I one of your hosts? Because I'm on your screen right now. So, as you guys probably are aware, this is a Math Kangaroo live solve hosted by two people. One of those is me, but I'm the less interesting one. The more interesting one you will see in a second, and that is Daniel He. Now, Daniel He, well, he is a USAJMO qualifier, math talent king coach, cello player, and just in general, he loves mathematics. He's really awesome. We're very lucky to have him today. Daniel, you want to say hi?
Yes, and actually, Megan said a lie earlier. Megan is actually the more interesting one of us two, and she's a national math counts competitor from Nevada and a Math Prize for Girls qualifier. And aside from math, she also plays violin and speaks Spanish.
Yeah. So, looks like you guys have already figured out a little bit about how our chat system works. So, if you send a message as a direct message to Chat Relay, that is the only way that we will be able to see it. And bonus feature of sending it to Chat Relay, you get to appear on screen right here, just like this wonderful person. I believe that is Mio, and they're answering the question that we have posed for y'all just to get you guys familiar with how this works, which is, where are you from? Math Kangaroo attracts people from a lot of places. We'd love to see where you're from. I think I've seen a couple people from Texas, a lot of people from Texas actually, Massachusetts, Michigan. How many of guys are there today? I'm actually curious now. 40, that's nice, nice. Georgia, California. California is nice. New Jersey. At least I presume that that's New Jersey and it's not orange juice what make it new, so new juice. Illinois, California. Oh, right. Other thing I want to explain. You will see that some of you guys have stars next to your names. That is because we have a lovely team of moderators here today. They serve two functions. One, to make sure that you guys are behaving yourselves. So if you are trying to not do that, do not expect to get far. Conversely, if you guys are saying good things, you will get stars. They appear next to your name and they make you look very cool and very swag. So, I strongly encourage you guys to send good things so you can get some very good stars. California, Massachusetts. Thank you, moderators. Yes, that is very true. Moderators are awesome. Math Kangaroo is cool. Math Kangaroo is cool, but not quite as cool as getting stars is. Okay. Daniel, is there anything I'm forgetting about?
I do not believe so. Well,
Okay.
let's just move on to the problems then, because that's what you guys are here for. Also, unfortunately, I cannot get any stars, so I cannot be cool, which is very sad. But
You're already cool, don't worry about it.
yay! I've been acknowledged as cool from someone who is very, very cool. So I feel good about myself now. All right, let's move on to the problems. So, Math Kangaroo is better. Yes, math is very fun. All right, but our first problem comes from, I guess, what you guys are here for, the 7th to 8th grade 2021 Math Kangaroo, and it's the first problem. And we want to find which of the following zodiac signs have one line of symmetry, one axis, I should say, of symmetry. So for these types of problems, I'm not sure if there's really a very good way to do them, except just look through all your answer choices. So the first one, Sagittarius, you have that thing, right? Well, if you just look at that line in the middle, looks pretty symmetrical to me. I don't know about that one. So it might be A. Scorpio, nah, there's like that thing over there, which is kind of throwing us off. Leo, you have a weird squiggly thing, and like you can't really flip that circle anywhere except for like any lines through the circle. But then any lines through the circle, just like it just doesn't work. Very sad. Cancer is kind of tricky because it looks very symmetrical. So it might be like a choice you might pick just because it looks like, oh, it's just flipping things over. But actually, Cancer, if you think about like what lines you can flip over to get the circles to line up, it's really only like that line down the center there, right? But with that line, things on the side just don't flip. They just flip to the other side here. So that doesn't work either. Finally, Capricorn, yeah, that's just not symmetrical. So our answer has to be A, Sagittarius.
Yeah, I think someone made a really good point about D, which was that it's a turn, not a flip. And so the important keyword here is that it's an axis of symmetry. So you can have rotational symmetry and like reflective symmetry. So that would be if you have like a point and you are rotating about that point. So like thing, thing. Or if you have a line and you are rotating across the line. But yes. Oh, I think I might have seen one thing about that was asking if the shape is upright or no. And so the thing there is that the axis does not have to be vertical, and in fact, it isn't vertical. So if we go back to looking at Daniel's diagram, you'll see that it's actually at an angle.
Yeah, so that line there, it's not like your y-axis or x-axis where it's like that way or like that way. It's slightly curved, that way. But even though it's slightly curved, it's still technically an axis.
Yeah, exactly. So with that, I think we'll head on to our next question, which is how many 4-digit numbers have the property that their digits from left to right are consecutive and in ascending order? Okay, those are some very big words. So let's see if we can break that down. 4-digit number. Okay, not too big of a word. 4 digits. Their digits from left to right are in ascending order. So that means that you have like A, B, C, D, and they are increasing. As we go from left to right, they are ascending, they're getting bigger. And then we have that they are consecutive. So consecutive just means if we list out the numbers, and then 10 is not a digit, so they have to be, well, like one group of 4. So like 3, 4, 5, 6, 7. We can't skip any of them, basically. And looks like yours is saying B6. And I think I saw an explanation for this earlier, where you can look at the ending digits or the first digits. I think that's a great way to think of it. So yeah, important thing to keep in mind, you can't end after 9. You also can't start with a 0. So with that in mind, we can start with a 1, 2, 3, 4, 5. But it's when you start with a 6, this one right here, you end with a 9. So you can't go past that. Lucky for us, it's very easy to see how many numbers there are from 1 to 6. It's 6. So our answer is yeah, 6, just like yours are saying. Yeah, we could also count based off of the ending numbers. You do have to do a little bit more math there, just because if I ask you how many numbers are there from 4 to 9, the answer is not 9 minus 4, because, shoot, I'm blanking. The answer is not because math, but that's the best answer I can give you. Daniel, can you give a better explanation?
Yeah, it's kind of tricky, these types of problems. It's kind of how, like, if you think about the numbers between 1 and 6, there's 6 of them, right? Even though 6 minus 1 is 5. It's because if we just subtract them, we actually don't count the number at the end. So if we do 9 minus 4, we don't actually count the number 4. We just do 9, 8, 7, 6, 5, right? Those 5 numbers. So we're missing that 4, so we have to add 1 to compensate. But either way, you get the answer to be 6.
Yeah. Oh, and I remember the way that I normally think about it. And it's that you can think of subtraction as finding the distance between 2 points. So if you have yourself a nice little number line, right? With, say, 4, 5, 6, and 7. 7 minus 4 is this distance. But you'll notice that that's 1, 1, and 1, which can correspond to like the first 3, but you leave off the last one, or the last day, but you leave off the first one. So if you've ever seen that tricky problem that's like, how many cuts do you need to do to cut a log into 4 pieces? It's that thinking.
Yeah, that's a really nice way to think about it. All right, let's look at our next problem then, where we have a bunch of adding. Oh, let me slide over here. And we want to add this 4-digit number composed of A, B, C, and D, where A, B, and C, D are just numbers that satisfy this equation, where AB plus CD is 137. Well, maybe let's think about why they didn't tell us anything about A, B, and CD other than they sum to 137. Because if they don't tell us anything, that really means any value of A, B, and CD that should satisfy this one equation should work for all equations. In fact, this is a cool math computation trick. Because this is a multiple choice and not a proof-based question, one answer is all you need. So if you can find one answer, you're done. So if you're somewhat low in time, you could just find two-digit numbers, A, B, and C, D, such that they added to 137, and just work with this. And you'd be done. But we're not going to do that for the sake of completeness. Let's just look at what we have here. It's blurry. So the first number, we can, like A, B, C, D, it's really 1000A. 1000A plus 100D plus 10C plus, I got that wrong, D, C plus D. And the other number is 1000C plus 100B plus 10A plus, what's the last one? D. That's a B. I can write. But one thing we can notice is if you think about these two, that's really just, in fact, if we draw it on the board and just draw this line between, that's really just AD plus CB. But we know when we're adding, it doesn't matter what order we add them in. And we can just switch the ones digits, right? Because it's addition. So that actually is just AB plus CD, which we know is 137. So the sum of that is 137. And 2 zeros, of course, because these are like hundreds and thousands of digits we're adding. And then the other one, we can do the same thing. If we switch the positions of the C and the A, that just becomes, again, AB plus CD, which we also know to be 137. And if I have 13,700 and 137, all I have to do is add them up, and that will give us our answer of B.
Yeah. And yeah, so to expand on what Daniel was saying from earlier, we most definitely can plug in numbers. So this is building off of something I believe is generally called either a cryptogram or cryptorhythm, except for there is no unique solution, so we can just do whatever we want. So for example, B plus D, what if we do 2 and 5? Well, that makes 7. And what makes 13? I think 6 and 7 makes 13. So then all that's left to do is fill in some numbers and do some addition. So that's what? 6, 5, 7, 2 plus 7, 2, 6, 5, I believe. Notably, this seems very annoying to do, but we can do it anyway. 7, 3, carry the 1. Well, 1 plus 7, that's 8. 1, 3. Well, isn't that convenient how that worked out? Gee golly whiz. Notably, this would also work if we'd chosen stuff where it carried over. So, like, if we chose 8 and 9 and then, like, 7 and 5. But, yeah. So, like Daniel mentioned earlier, there definitely can be other numbers. But as it turns out, if we can choose some valid numbers, then it'll give us the solution. Because it has to be valid. The solution has to be correct for any correct like subset, basically. But yes, we can also solve this more rigorously, like Daniel pointed out. So yeah, it's a very nice problem. And if you like this sort of stuff, I think that this sort of problem where there is one unique solution, I find those problems very fun. You should definitely check them out. Yeah, okay. Oh, fun. Okay, Byron is 5 centimeters taller than Aaron, but 10 centimeters shorter than Karen. I love these names so much. Darren is 10 centimeters taller than Karen, but 5 centimeters shorter than Aaron. Which of the following statements is true? Okay, immediately I'm not saying Aaron anymore again. A, B, C, D, and E. That's our first order of business. Our second order of business is I like number lines. So I want a number line. So let's go get me a number line. Isn't this lovely how mathematics just does exactly what you want it to do? So, number line. That is way too horizontal. Okay. Better number line. So, first person, B. B is 5 centimeters taller than A. And 10 centimeters shorter than C. D is 10 centimeters taller than C. And 5 centimeters shorter than E. Okay, that should be the correct diagram. So now we just have to see which of these are true. And these are all describing Aaron and Aaron. This was not made to be read aloud. Okay, all of these statements are describing the height difference between A and E, the people, not A and E, the answer choices. So, based off of this diagram, we can add these up to see that A is shorter than E by 5 plus 10 plus 10 plus 5, which is 30, which gives us the answer choice of E. I dislike that very much so it might be advantageous to just go and double check that they are in fact in alphabetical order. So yes, B is taller than A and shorter than C. D is taller than C and shorter than E. Okay, so yeah, we add that all up, we get 30, and I never want to see this problem again, so I better have gotten it correct. Yes!
Mathematicians are very, very clever when coming to naming sense. Like we can name things A, B, C, D, and like, I don't know about you, but those are common names we find in normal human beings.
Who have you ever met named Karen? Sounds like a Care Bear. Karen the Care Bear, come to spread joy and positivity through suffering of ye mortals on earth.
That sounds like most math competitions, so.
Honestly, yeah.
Let's move on to our next problem. If I can find our next problem, that is. All right, here we are. So, for our next problem, we want to find the area of the white flower. This is a very pretty flower, by the way. Whoever designed this has good artistic sense. So, here we want to find the area of the white flower, and it isn't immediately obvious to us how we could do that, right? Well, one thing we could do is we can consider the white flower as little triangles. And if we do that, let's also label some numbers here, because numbers are always good. So the area of the large square is 16 centimeters squared, which means the side length is going to be the square root of 16, so it's going to be 4. And each of the small squares are 1 centimeter squared, so that small side length will be 1. So let's just relabel all these. So that's like 1, that's 1. So the middle part has to be 2, right? And if we drew a line down the middle here, I guess it'd be better to draw a line down the middle there. This distance is also 2, right? It's probably a little small. Let me zoom this in. Things have moved. Mildly unfortunate. But yeah, this distance here from this side to the center will be half of the whole square because this flower is like, it's perfectly symmetrical, right? Doesn't matter how we rotate it, how we flip it, it's perfectly symmetrical. So it makes sense if this distance is 2. And if this distance is 2 and the square distance is 1, or this square side length is 1, the difference between those two, and therefore, this diagram is really small, this red distance here has to be 1. And that's just the height of this triangle here, right? And the base of that triangle is just the base of that square, which also has side length 1. Which means each of these little white triangles has base 1 and height 1, which means they have area of 1 times 1 times 1/2 is equal to 1/2. And since there are 8 of them, well then the total area would be 8 times 1/2, which is 4. So that's answer choice C.
And I do see a couple of people who are doing it basically the opposite way. So they're looking at what is not part of the flower and subtracting that from the total. Because we already know that the big thing has an area of 16, and that each of our squares have an area of 1. So all it's left to find is the area of these triangles. So, like Daniel said before, 4, 1, 1. So we know that this is 2. And also that the height of this is 2 because that's half of 4. So we have 4 triangles, each with area 1/2 base times height. And that also gives us C, or 4 centimeters.
Yeah, geometry is really nice that way, where you can do stuff so many ways and get the same answer. Like for example, if I said that bottom corner there was the point 0, 0, I could actually find the points of all points on the white flower, and I can use something called the shoelace theorem. I think that's the best method to solve this problem, actually.
Shoelace theorem is always the best method to solve anything. Coordinate bashing is peak, just top tier. Oh, real quick, there are more of you guys than when we first explained this, so I'm just going to say it one more time. If you want us to see your messages in chat, because we would like to see your messages in chat, you should send them as a direct message to Chat Relay. If you do that, they show up here. It's very neat, very cool. Do I look enough like a Twitch streamer to say it's very poggers? Anyhow, yes, Chat Relay is awesome.
Also, if you send good messages, you get stars, and stars make you very cool.
Stars make you very poggers. I'm very hip and cool if the kids don't laugh at me, Daniel.
It's okay, I'm laughing at you.
I'm hip. I'm with the times. You should show shoelace theorem, though, because it's a really cool way of doing this.
I don't know if it's the most efficient, but it is very cool.
Okay, how about if we have time at the end, then?
Yes.
Awesome. Well, in that case, we should probably move on to the next one to see if we'll have time. So, 5 squares indicated as shown. The small square has an area of 1. What's the value of h? Huh. Well, this is interesting because that's not a lot of information. So, let's see what we can do. Well, first thing is side length of 1 from area of 1. So that's progress. Next thing is I want to put a variable in here somewhere. I want a variable for, how about the side length of that biggest square? Right, so for no, not that one. For this one, we'll say that it has a side length of like x. So then that means that the next one next to that has to have a side length of x minus 1, because if you'll see here, this side plus 1 is x because it's a square. If we go up one more, then that's x. We'll move that up a tiny bit. X minus 2, because again, we're subtracting off the 1 for the square. And then up one more, we subtract off this one from the whole length to get that this is x minus 3. And you'll notice that if we look at h, we can say that h plus x minus 3 minus 1 to represent this little bit is x. And so then we just cancel everything out. So h plus x minus 3 minus 1 equals x. Cancel out the x's. H equals 1 plus 3 equals 4. That seem reasonable? I think so. Is that what you guys are getting? I've seen a lot of C, so yeah, that makes sense. And also, C is a pretty good choice if you're not certain, because, well, definitely not for certain. There's like a decent likelihood it's an integer. And so, if you're choosing between A or C, then yeah. A doesn't work. Yes, no, C is definitely the correct option.
Yeah, the first time I looked at this problem, I was like, that's not a lot of information we're given. So what if we assume some numbers, you know?
Yeah.
Turns out not to have been needed, but if we were like, hey, that kind of looks like 2, you know? Just maybe. And then like, well, I guess the next one's a 3x3, and then a 4x4, and then a 5x5. That's also a valid way to solve it.
Yeah, we do need to be careful though, because if we get numbers that are too small, we could run into issues. So like if you remember, suppose we chose the biggest square to be 2. Well, you can't really subtract 3 from 2 and get a positive number. Or even like if you say that, if you said like, oh, let the big one be 3, so then that's a square of side length 0. I'd like to see that one. So yeah, we do have to be a little bit careful with that, but yeah. I see some people saying x equals 4, 5.
3 square.
Complex plane for the win.
Use assumptions
best method. I mean, for some questions. Not necessarily, but yeah, a decent amount of time.
Alright, let's go on to our next question, which hopefully is not geometry. Not geometry. It looks to be a word problem. I like word problems. Seem to be a lot of word problems in these Math Kangaroo live solves. I wonder why.
Curious. Math Kangaroo, for those of you guys who don't know, Math Kangaroo is a math competition, but it focuses more on like logic than like the quadratic formula. So it's going to have more word problems to present more like logical approaches. I think it's really cool.
Yeah. And this is a pretty good example of a logic question, actually. Because it's like, okay, I have a box of fruit with twice as many apples as pears. So let's say like I have 2 A apples and like P pears, or A pears, I guess. I should have said 2P and P, but too late now, I guess. And then Christy and Lily are dividing them up such that Christy has twice as many pieces of fruit as Lily. Well, if Lily has L pieces of fruit, then we know that, did I say Christy or Lily? Okay, if Lily has L pieces of fruit, then Christy will have the remaining 3A minus L. But we know that Christy has twice as many pieces of fruit as Lily, which means 3A plus L has to be 2L, which means L has to be A. So actually, Lily is taking A pieces of fruit, but from split among the two A apples and A pears. So let's say she takes B, because we're very clever in naming. She takes B pears. Well, then she'd have to take A minus B apples. Which means, conversely, that Christy will have the remaining A plus B apples, and we'll have the remaining A minus B pears. So let's see what our answer choices are. A. Christy will take at least one pear. Well, that's not necessarily true, is it? Because Christy's pears are A minus B. So, for example, if Lily took A pears, I guess an easy way to do it is like, if there are two apples and one pear, and Lily took that one pear, Christy does not have at least one pear. So the first one's wrong. What about number two? Christy took twice as many pears as Apple. Okay, let's do that one again. Let's say Lily took one pear, Christy takes two apples. Two apples is not twice. I guess one half in this case, of 0 pears. So it can't be B either. C also doesn't make sense. Christy took twice as many apples as Lily, because we do the same thing again. Lily would have taken 0 apples if she took one pear, so it's not C. And now we come across D and E. D is Christy took as many apples as Lily got pears. Well, Christy takes A plus B apples, and Lily gets B pears. So D always has to be true. Wait, did I put those? No, I think, yeah. So D always
No,
has
you
to be.
definitely
Oh?
D. It's because it's not D, it's E. Because B minus A is B minus A, but the other two don't have to be equal.
We're sorry, what I do?
Right. Okay. So the okay. So how many apples? Oh my goodness. Let me pin you because okay. So the number of apples that Christy took is A plus B. Yes. Which is not the number of pears that Lily has because A plus B is not B. Because A does not have to be, A is normally not 0.
Oh, I read that. I thought that was like as many as in like greater. Oh, that makes sense.
Oh, yeah, no. Yeah, that's a good thing to keep in mind here. Yeah, here as many means equal to, but yeah, I could see how you could think it's greater than or equal to. I think if they wanted that, they would say took at least as many.
That makes sense. Oh, okay. So D isn't right because we have like A plus B and B, but E is right because we have A minus B and A minus B. Oh, that makes sense. Be very careful about the wording, guys. Wording is tricky.
Yeah, and I like how we were able to get through a decent amount of that with assumptions, just like before. So yeah, we could just say, like Daniel showed, we could say 2 apples, both apples to Christy and 1 pear to Lily, but we could also just look at the symbolic way of writing this out. A minus B can be 0, and just go through all of the others. The only one that's necessarily true is A minus B is A minus B. Yes. Very good job, y'all. Oh, fun. This looks too much like geometry for me. Okay. A cannonball is labeled with A, B, C, D, or E, 4 of each type. And this is the labels on the cannonballs of 3 of the faces in the pyramid. What is the label on the hidden cannonball in the middle of the 4th face? Okay. So I think the easiest way to do this is to see if there's anything we can do. Because remember, so if we think about this, right? we're going to have corner pieces, edge pieces, and our center piece. And so these corner pieces are going to show up well, one of these is going to show up 3 times, and the others are all going to show up 2 times. And as for the edges, we can match them up. No, this doesn't seem, so I was hoping we'd be able to do some nice cancellations, but I'm not entirely sold on that. Yeah, we can definitely bash this out. We can match up everything. That's definitely what I would switch to if this was a competition, but I am curious if there's a non-bashy solution. So yeah, so I see Daniel's already done a lot of very nice work to figure out how they match up. And basically, you guys can't see this, so I'm just telling you this to know that this is not an original idea. But basically, the way it works is that they have the same top, so D is at the top, and then we match up this side to this side, this one to this one, and this side to this side. So we match all of those up. And then with that, we can just go through and count a tally. So we have A, B, C, D, and E. And then we can just move down. So for D, we have a top. Oh, okay. Here, let me finish doing this, and then I'll show you something cool that's more related to what I was thinking of. So, and then along the edge from here and here, we can see that we have a C, a B, and a D. For the edge that's here and here, we can see an A, D, and A. And then for our last edge, that's going to be the one that's, which one is that? Okay, that's going to be this one and this one. And that is a B, C, and E. And then we look at the centers. So that's E, A, C, and then at the bottom, E, C, B, A, E, D. If I'm not mistaken, which I very well might be. I am. That last one was not a D. That last one was a B. So that means that D is the one without enough. So that is definitely the answer. But what I realized earlier, right, is, was I thinking of this correctly? No, I wasn't. Okay. If you know which one is the top, you don't have to know how they line up, because we know that, well, think about how we counted this, right? So we know which one's the top, and we can count that once. We know which ones are on the shared edges, and we count those in half, and we know which ones are the middle or the unshared edges, and we count those once. We do have to know which one is the top, though. I wonder if there's a way we could figure that out without matching it up. There is. Okay. Is there? Yes, there is. Okay. I'm being very big brain right now. Okay. So, the one that's at the top will appear in all 3 of these, and the others will appear in 2. So if we count how many times each letter shows up at a corner, and we look at the parity, the odd one will be the one that's that. So which one is odd? Well, we have D times 5, A times 2 and C times 2. So I'm pretty sure this is the odd one. Which means that then we just have to figure out which is the top for each of these. So we know that that's the D in this one. That's always with the top. And we know that the A over here has to match to this A. So that means this is at the top, and same with the C. So same result, but with a little bit more fancy math terms like parity.
Yeah, this problem feels like this problem is not very fun. If you like just look at my board, this is pretty nasty stuff if you like don't think about any of the parity or anything. So yeah.
It's really fun though, like it's putting together all the little pieces.
Yeah, definitely. But I feel like if you're like to try to draw this out during the actual competition, it would be so much of a pain. Type sync. But yeah, this is a cool problem.
Oh, looks like someone actually drew it out. Oh no. You sweet summer child, you did not deserve that. Did you get the right answer though? I'm waiting for the Math Kangaroo question where instead of A, B, B, C, C, D, D, E, E, they just mix it up. So like your answer choices are like A, B, B, D, C.
That's so evil.
Waiting for that one.
Imagine like you do all the work, you get the correct answer, and you're like, oh, I got C. And like C's answer choice E or something, and you just bubble in C. Ah, that'd be tragic. Alright, our next problem is about soccer balls. World Cup. World Cup is very fun.
Oh, you know, I made a giant bracket on my wall for my Spanish class for the World Cup. It's a lot of fun.
Oh, really?
Who are you guys supporting? No sports. What about you, Daniel?
It's very cool how South Korea got into the qualifiers, which I thought that was nice. Because we all thought like they had no chance because, yeah, Uruguay was beating them, other team. But then last minute, they scored a goal, other team, like on the other game, they lost. So they got to advance. It's really cool. But yeah, so our question is, how many hexagons are there on a soccer ball? So this is like one of the questions where if you play soccer and you memorize this number, you're done. Unfortunately, I do not play soccer, or I used to play soccer, but I don't anymore. And so I don't know the answer to this one, so we actually have to do it, which is kind of sad. Unfortunate. All right, one thing to notice for this problem is for every side of a pentagon, it doesn't connect to another pentagon, right? It connects to hexagons, which means every side of a pentagon connects to a hexagon, and there are 12 pentagons. Therefore, there are 12 times 5. 12 times 5 is equal to 60 pentagons. And then we look, and 60 is not an answer choice, so now we are incredibly sad. But then we also can notice that every hexagon is next to 3 pentagons. And if every hexagon is next to 3 pentagons, that means we've overcounted a whole lot, haven't we? Because what we said was just every pentagon has 5 hexagons, but now every 3 pentagons share a hexagon. So all we do is just divide this number by 3, and we get the answer of 20, which is D. Yeah, and someone says they Googled it and said got the answer was 20. Yes. This is why you have to memorize all sports facts before ever going to any math competitions.
Actually, this is why you should go to math competitions, so if you forget sports facts, you can just figure it out on the spot and seem smart. Yeah. That is a very smart way of thinking about it. One thing I want to point out, though, if you're not quite smart enough like Daniel to figure out you can do quick maths, you can also look for patterns so that you don't have to count quite as many, but you still do a little bit of counting. So for example, if we look at the top and bottom pentagons, those both have a ring of 5 hexagons around them. And in between those two rings, we have this up and down thing that we can see is actually 10 hexagons wide. So we have 5, 5, and 10. If you can't tell it's 10, that you can look and see 1, 2 hexagons per hexagon up here. So, works out very nicely. Daniel's got a great picture of what I presume is ocean soccer, but it might also be an illustration of what I was talking about.
It is totally ocean soccer. That's 100% ocean soccer. Yeah.
Okay, I wonder if this next one's about oceans. That would have been so cool if I was right. Honestly, this is better. Knights and knaves, a wizard divides 2020 of the 2021 people into 1010 pairs. Is it 1010? Would it be 1010 pairs? If it's 2020, it's probably 1010. Okay. Every person in a pair described the other person as either a knight or a knave. As a result, 2020 people were called knights and 20 people were called knaves. How many pairs of 2 knaves were there? Okay. So, we know that we have one person who is either... Remember what we said about Math Kangaroo being nice and letting us use A, B, C, and D? Not anymore. Okay. A knight or a knave. I hate using the letter I because that normally means the square root of -1, but I will suffer through this. You know what? No. G. It's a G for knights. And an A for knaves. Okay, anyhow. So we have some knight pairs who are going to report 2 knights. We have some knave pairs who will report 2 knaves. Nope, not 2 knaves, 2 knights. Because remember, the knights are going to tell the truth about each other, and they're going to say that they're both knights, as they should. And the knaves are going to lie about each other and say that they're both knights. Now, what happens when we have a knight-knave pair? Well, the knight tells the truth about the knave and says they're a knave, and the knave lies about the knight and says that they are a knave. So we get 2 knaves reported. Math problems are always unrealistic. Honestly, this is one of the most realistic math problems I've seen. Like, the other ones are like where do you find Aaron, Baron, Karen, and Darren all in one spot? I believe this way more. So, unfortunately, I do have to solve this. Yes, John buys 500 watermelons. The classic. Okay, so now we want to know how many pairs of knaves there were. So, we know that, nope, I was just not thinking this through. So, 20 people were called knaves. That means that there were 10 knave-knight pairs. So, what does that mean for us? So there were 10 of these, which means that we have, well, 11 left to deal with. We know that they're all paired up evenly. So, Daniel, what on God's green earth is that?
Daniel, John is buying his 500 green watermelons. These are very realistic math problems. I don't know why people are saying like math problems aren't applicable to real life. This is John. He's right here.
Anyhow, now that we've got that mind rot out of the way, so we have 11 knights, and we need to put them in pairs, and we can maybe use this one extra dude. So 5 pairs plus we know that our knight is the extra dude. So We have 10, 10 pairs, 10, 10 minus 10 minus 5, 9, 9, 5. So that's option D. Pi pies, I hate you all so much. See. Oh, okay, so that's actually a different answer than what it seems like the most of you got. So I might want to take a look at this a little bit closer. Aren't there 20 pairs of knights and knaves because there are 20 knights? Okay, so there actually do not have to be 20 pairs of knights and knaves because we can have some knight-knight pairs. That's what this is, GG. And so we can't really distinguish a knight-knight pair from a knight-knave pair, but we know that there are 10 knight-knave pairs because each knight-knave pair is going to report 2 knaves. And we know that there are 20 people reported as knaves, so we have to have 10 pairs. And then after that, we have to figure out what on earth we're going to do with our 11 knights. And luckily for us, these are in multiples of 5, so even if we got this part confused, it wouldn't really be it wouldn't be a deal breaker. But, so we put 1 here, we put 5 here, and remember, we've put 10 of our knaves into here. Huh, wait, that's not how math works. No, it is. Okay, let me show you why that's how math works. So, okay, we can also think of it, we can use the total number of pairs, or we can say we've put 10 knaves into here, so since we had 2020, we subtract 10, which is 1990. How many pairs of 2 knaves are there? Those are the knaves not in a knave-knight pair. And that is going to give us 995 because we divided by 2. Can you find an image of the towns of 21 knights and 2,000 knaves? No, because they didn't have photography back then. Okay, I think we do still have people who are still confused. Daniel, do you have another solution that might be able to help them out?
Yes, I do actually. So, also, there are 5 axioms in math, and one of them is just what Megan presented, because it is the truth and the fundamental truth behind math. Anyways, so
what did I say?
we have. Nah, you just said like you were going to explain how math works.
What about math?
How math works.
Math doesn't work though.
Perhaps there are no axioms of math. Alright, but we have 10 pairs of knights and knaves, right? Wait. Oh, that's why you're using the G and A. Okay, we're gonna call them K and I and K and A because G is a bad letter. So we know we have 10 K and I's and 10 K and A's because we have to have 10 people who call each other names.
Ignore the question. What's wrong with G?
G doesn't symbolize a knight. K and I symbols a knight. Like when anyone ever says G, you don't think of a knight. But when anyone ever says K and I, the first thing you think of, knight. Just like K and A. Like whenever someone walks up to you and says something about K and A, you automatically know they're talking about names. Like what else could they be talking about, you know?
Nate. Like a knight, but with an A.
Oh, that's true. Perhaps we need to have a KNAV and a KNIG. So we have a nigh and a knave.
No, but there's no H after that, so that's just a knig.
Ah, knig. So we have 10 knigs and 10 knav. Knav?
Knavs.
Knig? Knav, okay.
Knav.
Yes. So we know 20 people need to call each other out for being knaves, right? And if we have 2 knights, they'll both say, hey, we're knights, and knights are cool. And then if we have 2 knaves, one knave will look at the other and go, hey, that's a knave. But they always have to lie. So they'll just both point at each other and say they're knights. which means to have two people look at each other and call each other knaves, there has to be one knave and one knight. And since there are 20 people doing this, there have to be 10 knights and 10 knaves. But
I'm
wait.
sorry, someone just said make it 10 knives, and I am totally on board with that.
Knife. Okay. We're going to go with 10 knives and 10 knights.
Why are people talking about knives? It's because if you... So we were... Let me clear my screen for this very important math talk. Kn is at the start of both knave and knight. So we can write Kn, Ka, but that's not necessarily enough to distinguish them, because what if you swap the endings? And then, instead of a knave, you have a... Would this be a gnat, like the insect? It might be. You might pronounce that like a gnat, like an insect. I mean, it is a knight, so why wouldn't it be a gnat?
Oh, that's true. Knight and knave both have silent Ks, don't they?
Yeah. Is it knight? Okay, so it's not knight. Would it be knat, nate, or like gnat, like the insect? Okay. But anyhow, if you do the opposite, you get knive. I promise we're not threatening violence. This is just dumb English.
I see Anthony, Anthony says L for lie and T for truth. That would be smart, but being smart is difficult, so we're going to skip over that.
Okay, but see, the thing is, Anthony did not have the foresight to remember how you write in math, because this could be a lowercase l, an absolute value, an uppercase I, or like a lot of other things. So you have to always write it in a cursive L, and I'm surprised you did not do that properly. I'm very disappointed.
Yeah, imagine not using cursive L's in chat relay. How could you guys? Yeah, but if we have 10 knaves and 10 knights, and we have like 20 people, it's cut off. 20
Oh yeah,
people,
guys,
right?
okay, to be clear, we saw you guys saying do T or L, but we have just elected to not. So don't worry, we saw that.
But if you have 20 people, and I think it was like, what, 2,000 knights? Sorry, knots. And 21 knives? Well, we can't have that extra knife just hanging around, right? Because knives are bad. Don't cut yourselves, kids. Always use safety knives. But yeah, knives are bad, so we'll just throw away that extra knife, you know? So now we have 20 knives and 2,000 knots. Well, 10 of them are in pairs with the 10 knives, right? Which means remaining, we just have 1,990 knots. Oh, like kind of like knots, you know? Knots.
Like the measurement of speed when you are on a boat.
Yeah. Are knots nautical miles?
No. I think it's like a measurement of nautical miles per time. Let me look it up, actually. Yeah, it's 1 nautical mile per hour.
That is actually good naming sense, because knot starts with knot.
No, but not nautical miles are with an N, and not starts with an
Nautical miles.
Okay, but what do you think about the insect known as the gnat?
Nautical miles. The number, or what would it be? It would be the number of gnats that fly at 1 knot. So 1 nautical mile per hour. I don't know. But yeah, okay, going back to the problem. If we have 1,900...
Yeah, someone said D for distraction time. Real quick, we did find the solution. The solution is D. It is technically 1 minute from the end of this. We are having a lot of fun. We will not be leaving now or probably in the very near future. If you have to go, we understand. Thank you for joining us. If you want to stay for a discussion of nautical miles, we would love to have you.
Yes. Nautical... How would it... Nautical miles. To the person who says English is weird, yes, but it is also very
Just
fun.
factually correct.
Natical. Oh, like just remove the U. Oh, I did that. Would it be? Could you do like GNAU? Would that still be natical, or would it be like something else? Hmm. Deep conversation indeed. This is
It's
this is one
almost
of the
as deep as
fundamentals
when
of
you were
math.
going deep into the ocean at 1 nautical mile per hour.
Hmm. World's deepest conversation in the world's deepest ocean. Buffalo, buffalo's buffalo. Buffalo. No, it would be buffalo, buffalo, buffalo. Because it's like not buffaloes, because buffalo is plural. So it's buffalo. I guess the second one is
How did the
lowercase.
topic change so fast? The topic was never on anything in particular.
Shipping, shipping, shipping ships. That does make sense. That is a viable sentence. I like that sentence. This is what mathematicians live for. So true.
What mathematicians live for is to be on a ship, to be shipping other mathematicians that are also on ships that are shipping.
Yes.
Get a job, you have all the tea about your coworkers, and you can start to ship them.
If you think about ships as animate objects, you can say that ships ship other ships. Because, like, shipping.
Yeah,
I don't
someone asked,
know.
this is fun, can we do this instead of math? Notably, this problem that we have pulled up is the last problem prepared for us. You'll notice the last slide I have for you today is some QR codes. Now, they're very nice QR codes, so I'll leave them up for you guys for a little bit. We might continue this final explanation of the problem at some point if Daniel is not further distracted, but that is not necessarily guaranteed. So we're here to have fun and to show you guys the math in the process.
Buffalo NY. The buffalo from Buffalo who buffalo. The what? The buffalo from the buffalo. Okay, so like the buffalo. Okay, the buffalo who buffaloed by who are buffalo by buffalo. So it's like buffalo. So buffaloes from Buffalo. Buffalo. So we're bullying buffalo. So like buffalo. This
Well,
is
Daniel
more
thinks that
thinking
this
than
for
the
the
actual
person
math.
asking what's going on, because math is never expressed in its purest form, is instead tainted by English. We have become distracted by the incredible burden this has placed on our lives, and we are now discussing it. Also known as someone said buffalo a bunch of times, and they claimed it was a sentence, so now it is. We're also talking about knives.
Recursion is the fatal flaw of math. That's not
No,
true.
recursion is great. I mean, to be fair, you spend all of math trying to figure out how to change stuff out of recursion into an explicit form, but was that the last question? Yes. In theory, we are still going over another way to think about it, but yes, that was the last question that we have. What about Gödel's incompleteness theorem? I don't know. It doesn't seem like a complete enough theorem for me to consider looking at it, so I haven't yet.
Oh, if you
Yes,
guys
thank
want
you
to
guys for
think,
coming.
here's something cool about recursion. So,
Yes.
let me go into lecture mode because recursion is very cool. So, let's think about a regular difference equation. So, like, a difference equation is like some like f of x plus 2 is equal to like a f of x plus 1. So, like, this is like a basic first order difference equation, right? Because all that's happening is you have an a and your term. And this is like your recursion. Oh, shoelace. We can go over shoelace. Yeah. Actually, yeah, this isn't relevant. But once you learn differential equations, there's actually a very strong tie between difference equations and differential equations. Namely, this one has I forgot what it was called, but like you can guess solutions of polynomials, and differentials, you can guess solutions of like e to the x to the powers. But yeah, shoelace is not time
Differential
consuming.
equations is bad.
Ah, differential equations are so fun. And you can use Laplace transforms on differential equations, and things just like it's like estimating a differential equation with like a chart. And it's so good. All right. Back to the shoelace problem though. As I've been saying. We'll get there one day, one day.
Well, shouldn't we finish solving the knights and knives and knaves problem first?
Never.
And we did solve it, but
Yeah. Okay, so the explanation for that I had back here is like you have 1909 hide that. 1999 gnats. So these are like the names, but we changed the VE to GHT because like why not, you know? So we have 1990 gnats. And if we divide that by 2, because every gnat has to be in a pair with another gnat, that gives us our 995. So that's just another way of thinking about it.
yes. Shoelace is time consuming. I don't care. Just because you can't tie your own shoes doesn't mean that we shouldn't teach other people how to.
Yes, this is one of the best theorems in math because it renders geometry algebra, and algebra is just a better subject. So how we would do this is
Algebra is the more popular subject.
yes. Let me find a student. Yeah, there we go. So let's say like I think it's better to have like the middle point 0, 0 and just use symmetry. So if we find one of these, right? That height here is 2, and that distance here is 1. So this is a point 2 comma 1 comma 2. This is the point 1 comma 1, and this is the point 2 comma 1. So what we do is we set up a shoelace. So we just braid chords of 0, 0, 1, 2, 1, 1, and 2, 1 together, and that gives us an answer that we want.
Okay,
So
that was the worst way I've ever heard someone explain shoelace.
It's like you like do the thing, you
Okay,
know,
here. Let
and
me
the thing
get
is
rid of
done.
my thing and show everyone real quick. So we have 0, 0, and so we have to go in the same direction. I think I don't know if you're supposed to go clockwise or counterclockwise, but you have to go in the same direction. So let's go clockwise, starting at 0, 0. 1, 2, 1, 1, 2, 1, and then you repeat the last one. Now, the reason it's called shoelace is because then you're going to do a bunch of multiplication like this. And then you multiply these, and it looks like a shoelace. So let's do those all one at a time. What's 0 times 1? 0. 1 times 2? 2. 2 times 1? Also 2. 1 times 0? 0. 0 times 2. Gee golly, I wonder what that could be. 1 times 1. 1. 2 times 1. 1. 2 times 0. No clue whatsoever. Okay, that's step 1. That's the really aesthetically pleasing part. Then we get to the hard step. We have to do some addition. So what's 2 plus 2 plus 0 plus 0? 4. 1 plus 1 plus 0 plus 0? 2. We subtract them, divide by 2, because that's just how the formula works, and we get 1 for the area of each petal. What's 1 times 4? Well, I'll leave that as an exercise to the reader because I'm a very good textbook writer.
Nah, you can only leave like the really complicated theorems that no one will ever get. Just like exercise to the reader, you know.
So what I should just say, so you just take all the chords and you braid them, you make a shoelace, and then you get the numbers. And then, as you'll see, 1/2 of 2 plus 2 plus minus 1 is 1. And so now you understand.
Yes.
And if you want to more in-depth demonstration, that's your exercise to the reader.
Oh, is Fermat's last theorem the one where like Fermat like scribbled a theorem and on the side notes he was like, hey, this took like a whole lot of pages to prove, So I'm just not going to include it and leave it up to you to figure it out. No one solved it for like the next 400 years.
Sounds familiar. I honestly do not have the brain power to keep the names of all of those theorems straight, but sounds familiar. I'm curious, how many people are still here with us, just vibing? 25. Honestly, that's like about as many we had as when we started. I'm very proud. Dude, what does my face look so pink in that? This is unacceptable.
Megan using pink lights and wondering why her face looks pink.
Excuse me, I have a degree in color theory. This is not supposed to be happening to me, okay? I am very smart and... No, I actually did set up my lighting so that my face wouldn't look pink, but apparently that did not go to plan.
Ah, that's unfortunate. Didn't the lights above your head used to be green?
Huh?
I could be misremembering. Oh, they're blinking.
Yeah, they're blinking.
Oh, fancy.
They're just one color though. I can change that. Let me show you. I don't do this because it definitely distracts people in general, but I can also change it to something like this. So have it do that. I also have one for seizure warning. But yeah, it can do a lot of very cool things.
I could turn my lights
I can also do
to
this.
another shade of green because I'm very cool too.
Wow, you're so cool. I'm so envious. All the things you can do.
I can even turn it to a third shade of green. Maybe. Maybe? Yeah. You can't tell, but that's slightly lighter.
When one other person leave, never. You gave me a seizure. My sincerest apologies. Can we make different lights, different brightnesses, of different colors, of different size? No. All of my lights do, they all sync to each other. I think, okay, this lighting is actually giving me a headache. Let me stop this. There is a way, though, to make it go along with what I am saying. So, as you'll see here, let me actually turn this down a little bit. But, so if I am talking, it will basically just sync my lighting to what I'm saying, because I am very poggers.
Fancy.
Does that work? Does what work? How? My LEDs have an app that you put on a phone, and a phone has a microphone. Maybe I should sing a song. What's a good song? Maybe I should not sing a song. That sounds like a bad idea.
Nah, you should totally sing a song.
La cucaracha,